Okay, so what exactly is resonance? Resonance is basically the frequency at which you will get max output. Now, what is output in a circuit? Current is the output of any circuit. So in AC circuits, resonance is the frequency at which we get maximum output. That's the simplest definition of resonance, the frequency at which we get maximum output. Now, thinking in terms of Ohm's law, we know I is equal to V over R, that's the Ohm's law. For AC circuit, it becomes V over ZT. And then for if we further break that down, we have V over square root of R squared plus XC minus XL whole squared, and which further breaks down to V over square root R squared plus 1 by 2 pi FC and minus 2 pi FL whole squared. These two are the formulas of XC and XL. Just write that down. XC is equal to 1 over 2 pi FC and XL is equal to 2 pi FL. Now, as you can see in this formula, the total impedance is affected by frequency here and frequency here. Okay, so the total impedance is affected by frequency. Now, if we were asked to get maximum output from a circuit, what could we do? We could do two things. Since I is equal to V over ZT, I is proportional to V, and I is inversely proportional to ZT. So to get maximum output, we could increase the voltage to maximum, or we could bring the impedance down to minimum. Now, increasing the voltage to maximum would be very expensive and so inefficient. However, decreasing impedance to minimum is much more feasible, and so we choose that route. Now, how exactly do we decrease impedance? We cannot change resistance in a circuit because the resistance just depends on the resistance is a fixed quantity and it depends only on the voltage and current, and we are not changing the voltage and current. But we can change XL and XC, which is the capacitive reactance and inductive reactance. XC and XL are basically the resistances provided by capacitors and inductors. Now, the formula of XC is 1 over 2 pi FC, and that means it is inversely proportional to frequency. So capacitive reactance or XC is inversely proportional to frequency. And inductive reactance or XL is equal to 2 pi FL, and inductive reactance or XL is directly proportional to frequency. Now what this means is if we increase frequency, capacitive reactance or XC will go down and inductive reactance or XL will increase. Again, if we decrease frequency, capacitive reactance will increase, but inductive reactance will decrease. So it's obvious from this that XC and XL are affected by the change of frequency. Now let's go back to the Ohm's law. So here we have I is equal to V over root R squared plus XC minus XL whole squared. This is the broken down version of the Ohm's law for AC circuits. So as we said before, R squared, we cannot change that. But we can change XC minus XL whole squared. We can change this. Now we want to bring this down to the minimum value. What do you think the lowest value of XC minus XL can be? It is a squared value, so any negative values will be turned positive. So we cannot say a negative value can be the minimum value for XC minus XL. So that means the minimum value for XC minus XL whole squared will be 0. And then we can derive from this equation that XC is equal to XL. So if we can get XC is equal to XL, we will have the maximum current output. Okay. Now that means if we can make the capacitive reactance XC and inductive reactance XL to be equal, this is our condition for resonance. At this condition where XC and XL is equal, we can get the maximum output and that is the maximum current. So at this condition, when we have XC and XL, the frequency at which we get XC and XL to be equal is what we call the resonant frequency. Okay. Another definition of resonant frequency is the frequency at which Xc is equal to XL is resonant frequency. Okay. Now, how do we get Xc and XL to be equal, or how do we calculate the resonant frequency? Now, there are two ways of doing resonant frequency calculation. We can calculate directly in terms of F, or we can calculate it in terms of omega. As you know, omega is equal to 2 pi F. Now, we just derive it from the equation Xc is equal to XL, and then 1 over 2 pi Fc is equal to 2 pi FL, and then we simplify it, F squared is equal to 1 over 4 pi squared LC. And finally, we have F is equal to 1 or square root of 1 over 4 pi squared LC. Alternatively, in terms of omega, again, X is equal to XL. X is equal to, in terms of omega, I'll just write the formulas. Xc is equal to 1 over omega C, and XL is equal to omega L. Okay, so we have that here. And then omega squared is equal to 1 over LC. And finally, omega is equal to square root of 1 over LC. And as I said before, omega is equal to 2 pi F. All right. Now at resonance, since we derived Xc minus XL whole squared is equal to 0. Okay, this is what we have at resonance. So that means in Ohm's law, we have V over I is equal to V over root R squared plus 0. This is where Xc minus XL whole squared used to be, but since that is 0, we put 0. That means our final Ohm's law for a circuit at resonance comes down to I is equal to V over R. Now, what does this mean? This means the RLC circuit, or the AC circuit that contains a capacitor and inductor, that circuit turns into a purely resistive circuit containing only the property of resistance. Okay, so at resonance, RLC circuit turns into a purely resistive R circuit. So questions may come in your exams, such as so if a question like says in an RLC circuit, V and I are in phase. That means that circuit is at resonance, which means Xc is equal to XL. Okay, V and I are in phase. We know that only happens in a purely resistive circuit.